All right, students, so now we're going to do case 2. Again, we're being very clear on this. In the future, you'll have to decipher this on your own, given one side and the whole segment. So this is why drawing pictures are very powerful, because before we would have just set 2x plus 9 equal to 5x plus 6. But once we draw a picture, R is the midpoint. So, boop, R is in the middle. That's T, that's Y. So now I know that I have TR, which is 2x plus 9, and I have TY, the whole thing. So I have to be a little bit clever. 1/2, the left-hand side, does not equal the whole thing. 1/2 does not equal 1 whole. If you think a half equals a whole, how about you give me 50 cents, or you give me $1 and I'll give you 50 cents if you think 1/2 equals a whole. All right, so common mistake, this is bad. People claim, well, we don't know this right-hand side, so that's X. That's false. False, not true. Arg. All right. There's a couple ways to solve this problem. Since R is the midpoint, we know the left-hand side is 2x plus 9. That means the right-hand side is the same exact thing. So the way I like to set up the equation, again, I just give suggestions. There's usually multiple ways to solve a problem. Whatever you do, just as long as it's correct, I'm okay with. I like just to do 2x plus 9 plus 2x plus 9. Some people, this is okay, this is legal, you're allowed to do this. This is the same thing. This is also good. They just like to multiply the left-hand side by 2. Either way, after you simplify the left-hand side, you're going to get 2x plus 2x is 4x, 9 plus 9 is 18. On both ways, you'll get this. I mean, if I just distribute this, 4x plus 18, it's the same thing. Just how you want to organize your work. And usually I like to try to get good at one technique, master it, and then use that all the time. So now I'm going to get 4x plus 12 equals 5x. I'm going to subtract 4x from both sides. And I'm going to get 12 equals x. And let's read the problem. It told me to find the value of x, so I'm done. All right, so read the problem. I'm done. Yippee. Yes, so happy. Okay, so cruising right along. So this is just nice. We're practicing our algebra skills. We're getting really good at the stuff we learned from our algebra teachers last year. Again, draw a picture. I know this is kind of consistent right now on exactly what's going on, but in the future it's going to bounce back and forth, maybe on the test, maybe on the quiz, maybe in the practice, who knows. Draw a picture. It's a good habit to get into. As you guys can see, I'm really good at drawing. I'm probably the best at drawing when it comes to teachers at Darby High School. Probably students and teachers, I'm probably the best drawer. All right, so we got this left side, we got the whole thing. So I'm going to say, hold up, since TR is congruent to RY, that means RY is also 10x minus 9. And in the equation I've set up, just using a good old segment addition postulate, 10x plus 9 plus 10x, or 10x minus 9 plus 10x minus 9 equals 25x minus 33. So simplify this left-hand side. Remember, 10x plus 10x is 20x. Minus 9 minus 18. And then we just got this right-hand side as well. And then I'm going to subtract 20x from both sides. I'm going to get 5x. Still have a negative 18 on this left-hand side. And notice how I work out, I don't do very much work. I mean, from this to here, not much work. From here to here, not much work. I just try to isolate and do one step at a time. I know sometimes you students like to try to do a whole bunch of steps. Then you're susceptible to a silly mistake, all right? Be tedious, be very thorough, be very detailed in your work, and it's gonna eliminate a lot of common mistakes. And I get 3 equals x. And that's what the problem asked, so I'm donezo. Cool. And one more problem, then you got 2 Canvas follow-up problems. Again, I don't know what the heck is going on with the computer. Hold on, I already forget. That's supposed to be 2x, oops, timeout, or x squared plus 1. Silly computer messing things up. Technology. Does anyone really understand how technology works? I'm not sure. All right. So we got r still the midpoint. Boop, boop, t, y. This is x squared plus 1. The whole stinking thing is 102. So that means that this is also x squared plus 1. So setting up this equation, I'm going to x squared plus 1 plus x squared plus 1 equals 102. So what's nice about this is that we're reviewing this x squared plus x squared. It's not, oops, I'm in highlighter mode. It is absolutely not, don't do this, don't be that person. It's not x to the power of 4. Some people think that. What it is, that's bad. Bad, not x squared or x to the power of 4. It's just 2x squared. That's the good way. All right, you combine like terms. Plus 2 equals 102. Then remember, we subtract 2 from both sides. So we're remembering how to solve for x. Because then students get confused. Do I do divided by 2 from here, or do I do the square root? Well, when we solve for x, it's reverse order of operations. So I'm going to save exponents from last. I'm going to get x squared equals 50. The square root of both sides, and then x equals the square root of 50s. It's 7 point something. It's approximately 7.1. Okay, and it just told me to solve for the value of x, is what I did. We got some follow-up questions on Canvas. Good luck and do your best.